Hello students, welcome to the next lecture on the Fourier series. Today I will explain you the several examples related to the convergence of Fourier series. I will explain you with the help of the 15 examples so that you can learn this topic in a very simple manner. Myself Dr. Harish, you can follow my YouTube channel where there is a playlist of the mathematics 2 and you can see the last lecture was on the Fourier series, examples of the Fourier series and many more available in this playlist. You must watch this lecture example of the Fourier series before watching this today's lecture. What is the objective of this? We will see how you can find the sum of the series and the convergence of the Fourier series. For example, if I say this is my question number 1, find the Fourier series of this and find the sum of this series. Similarly, question number 2 is find the Fourier series of this, find and show that this sum will be convergent to pi square by 8 and so on. How you can find the sum? Because this lecture up to this find the Fourier series that I already explained you in my this lecture example of the Fourier series. Now today I will explain you how you can solve these examples of the how you can find the sum of the series. I will tell you a very simple approach. You can watch till the end of the video so that you can learn many tricks to solving them. So as that objective is the two, that is the convergence and the sum of the series. If the given function fx, for example here fx is x square mod of x, fx is my this. If this function is my periodic and f dash are my piecewise continuous function, then you can say the Fourier series is my convergent. Once it is a convergent, then you have to find its sum. If this condition is not satisfied, then you can say the Fourier series is divergent. And when it will be the convergent, if it is convergent, then you have to find the sum. There are the two cases. First case is when f of x is my continuous at the point x is equal to a and the function is discontinuous at the point x is equal to a. How you can check the function is continuous or discontinuous? You have to find the left hand limit of the function and the right hand limit of the function. If they are not equal, is equal to f of a. If they are equal, then you can say the continuous, otherwise discontinuous. If you prove that the function is continuous, then the sum will be f of a. Whatever the function value, the sum is my f of a. If the function is discontinuous, then you can find the sum is f of a negative and f of a positive. Where a negative, what is the f of a negative? That means limit x approaches a negative of f of x and a positive is the right hand side limit. Now based on this concept, I will tell you the simple two-step rule. The first step is find the Fourier series and then you can choose the value of the x, whether it's a 1, whether it's a 0, whatever it is, from the given domain, and then you can easily find the sum of the series. How you can find the sum of the series? I again tell you, you must watch my this lecture in order to understand this completely, which is available at my YouTube channel. I hope you can subscribe my YouTube channel as well. So let's see. I will explain you the 15 example in this lecture so that you can learn it many simple way. Look at that. Whenever there is a question related to this part, find the sum of this series. And definitely in each of the examination, one question will be asked related to this concept. And it is of 10 marks or it's a 8 marks are here. Now, firstly, how you can find the Fourier series? We all know Fourier series is my this, where a0, an and bn is defined like this manner. Remember, if you are using the a0 by 2, then your a0 will be 1 over pi. So that's depending upon you whether you want to use a0 by 2 or you can use simple a0. Then you can substitute the value of the fx here and then you can find the a0, an and bn. So I am not explaining you how you can find the a0, an and bn because for that you must watch my this lecture. So after the calculation you will get a0, an and bn and after substituting this value you will get fx, Fourier series of function is here. Now remember, throughout my this lecture I am using here is a0 and a0 is my 1 over 2 pi. Now the most important concept. Your target is to find this number. Remember, listen very carefully about my how you can solve that. Always look about the denominator. Denominator is 1 square 2 square, 3 square and so on. So what is the form is n square. So look at this Fourier series. Do you have a n square term in this series? Yes, you have this term. Fine. If n square is not present in this one, it means your calculation is wrong. You have to check your an, bn and a naught. Second thing, once you get this denominator, this is from the denominator. Whatever the numerator is there, don't focus on the numerator. Now look at this sign. Whether it's all are my positive sign, whether all are my alternating sign, or all are my negative sign. So you can see it's a negative, positive, negative, positive. That means they are my alternating sign. How you can form the alternating sign? Minus 1 raised to power n. So do you have the term minus 1 raised to power n? Yes. This term also. It means we need minus 1 raised to power n and n square both. Fine. So look at this term. If you look about this from here, we need this quantity. We need this quantity also. So what is the remaining? What left is inside? So that is only left thing is, because 4 is my constant, so cos nx is my left behind. So what is the value of the cos nx? It may be 0, it may be 1, it may be minus 1. But if cos nx is 0, the whole quantity will be 0. That means n square will also be 0. So that means this is not possible. So now for what value of the x, so that this value becomes a 1? Can you find the value of the x from this domain so that cos nx will be my 1? So that's a very, very simple. When the cos value will be 1? At cos of 0. So that means you can choose x to be 0. So I can substitute x is my 0. Now if you substitute x is 0, this value will be f of 0. This is my pi square over 3 plus summation 4 minus 1 raised to power n over n square, because cos 0 is my 1. Fine. Now your target is to find this value. Check what is the value of the, check whether x is equal to 0, function is continuous or discontinuous. So clearly say x0 lies in between them. So the function is my continuous. So once the function is continuous, the value is directly you can obtain from this side. So what is the f of 0 is? 0 square, which is equal to pi square by 3. I can open this one. You can substitute n is 1. It is minus 4 over 1 square. When n is equal to 2, it is plus 1 over 2 square. Minus 4 over 3 square and so on. Fine. Now you can open this one. Now finally you need to this expression. So I can solve this. Minus pi square over 3 I can put on the left hand side. From this case I can take minus 4 common, because I need a 1 over 1 square is a positive value. So 1 minus 1 over 2 square plus 1 over 3 square minus and so on. So I need to find this value. Minus minus cancel. Pi 4 it can be written on this denominator side. Pi square over 12 is the required answer of this problem. Fine. So I again repeat you always look about the denominator, find the term which is appear in the denominator, and look about whether the term we need as a positive or positive, negative, and so on. Look at the second example. You will clear many things are there. So firstly, find the Fourier series of this. So your target is to find the a naught, your target is to find an, your target is to find bn. So once you can find this, you will get this is the a naught, an and bn. You will get this expression. Now look at that. Again, always look about the denominator. Denominator is my 1 square, 3 square, 5 square. It just like say n square form. Fine. Do you have the term which appear n square? Yes. So I need to preserve this value. Whether we need all as a positive or plus minus, all is my positive. It means we never need this number. Fine. So it means this is my constant. The only quantity is my here. So for what value of the x you can choose from this domain? For what value of the x you can choose an? So definitely, because this number can never be 0, because if this is 0, the whole quantity will be 0. So only needed is cos nx should be 1. For what value of the x, the cos value will be 1, cos of 0. Fine. So it means I can take x is my 0, and 0 is also the part of this domain. So that means I can substitute x is 0. So what is the value of this? F of 0, which is equal to pi over 2 minus 2 over pi summation n1 to infinity 1 minus 1 over n square. Cos of 0 is my 1. Is it okay? Now, what is the f of 0? 0 is the, what is that? 0 is the point of continuous. Fine. So it means what is the f of 0 is? 0. It will be pi over 2 minus 2 over pi. Now if you substitute n is equal to 1, it will be 1 minus minus plus 1 over 1 square. So that means 2 over 1 square. Plus, when you substitute n is equal to 2, this number will be plus 1. 1 minus 1 is 0. When you substitute n is equal to 3, this number will be minus 1 plus 2 over 3 square. When you substitute n is equal to 4, it is again 0. When you substitute 5, it will be 5 square, and so on. You will get this value. Now your target is to find this number. How you can find that? This pi by 2 I can written on the left hand side. I can take 2 as a common. So it is minus 4 over pi. It is 1 over 1 square plus 1 over 3 square plus 1 over 5 square, and so on. So your target is to find this number. Minus and minus will be cancelled out. So it is pi square divided by 8 is 1 over 1 square, 1 over 3 square, and so on. And that is the required proof of this result. Always remember, I told you, look at the denominator and then look at the plus minus sign. Look at more examples. Fine, I explain you with the help of the 15 examples. I hope you can like my video as well, so that I can understand it. You really understand this lecture. So firstly, find the Fourier series. You will get a naught, an, and bn. Now, look at the term in the denominator. What is the term in the denominator is? N square. Do you have the n square term? Yes, I have this n square term. Fine. Look at the sign, is all are my positive sign. So it means I need this value. So it means this number should be my 1. Fine. Then only you can go as a n square. So for what value of the x? X will be 0. Fine. Then only it will be 1. So again I can take x is my 0. So I can substitute on the left hand side. This is f of 0. Right hand side is pi square over 16 plus summation n is 1 to infinity 1 minus 1 raised to power n minus 1 over n square. Cos 0 is my 1. Sin 0 is my 0. So this value will be my 0. So you will get this expression. Now what is the f0? Check. Now you have the two cases. From the, what is the limit of the x approaches 0 negative? 0 negative is my 0. What is the limit of x approaches 0 positive? 0 positive is my 0. Both the limits are same. It means the function is continuous. So the answer is 0. It will be pi square over 16. I can open this bracket. You can substitute n is 1. When you substitute n is 1, it's a minus 1 minus 2 divided by 4 into 1 square plus, when you substitute n is equal to 2, this will be 0. Then when you substitute 3, it will be minus 2, 4 into 3 square, and so on. Fine. So you will get to, this is the expression. Now I can found minus pi square over 6 on the left hand side. I can take minus of 2 common. Minus 2 over 4, it is 1 square plus 1 over 3 square plus 1 over 5 square, and so on. Now you need to find this value. How you can solve that? It is 1 over 2. I can multiply them. Again, it will be pi square over 8 is my right answer of this problem. Look at this another one. So again, firstly you have to find the Fourier series. You will get a naught, an and bn. So my Fourier series is my here. Fine. Look at this term. The denominator you need only n. 2, 3, 3, 5, 7. That is only n. Do you have the n term present? Yes. Look at the plus minus sign. What is the need of this? You need a plus, then minus, then plus and minus. So you need a minus 1 raised to power n also. So you need a both quantity. It means I have to choose this value such that this value will be 1. So when the sign value will be 1, sign value will be 1 at pi by 2. So now it is sine n pi x by 2. So what is the value of the x? You can choose from this minus 1 to plus 1 so that this becomes pi by 2. So clearly say x will be 1 by 2. Then only it's a pi by 2. Fine. So it means you can choose x is 1 over 2. Fine. I again told you, firstly you have to preserve the denominator. This is the n. The numerator is plus minus plus minus plus minus. So I can also need this. The only unneeded term, the only term which we don't need is sine n pi x. So I can substitute it. It values f of half 1 minus 2 over pi, n is equal to 1 to infinity, minus 1 raised to power n over n sine n pi over 2. Fine. So you will get this. Remember, 90% student will do a mistake. What is the mistake is? The student will take this value to be 1. It is not true. Remember, sine pi by 2 is 1. But here is n also. It is not always 1. Fine. But believe me, 90% of the student will generally do this kind of the mistake. Now what is the value of the f1 by 2? f1 by 2 will be 3 by 2, 1 minus 2 over pi. Now I can open this bracket. When n is 1, it is minus 1 over 2. It is my sine. N is 1, so sine pi by 2, that is 1. Plus, when n is equal to 2, it is plus 1. What is the value of this? When n is equal to 2, 2 and 2 cancel, sine pi. What is the value of the sine pi? 0. Plus, when n is equal to 3, this number will be minus 1 over 3. This term will be sine 3 pi by 2. So what is the value of the sine 3 pi by 2 is? Minus 1. This is minus 1. When you take n is equal to 4, this quantity will be sine 2 pi. Sine 2 pi will be 0 and so on. Clear? So once you can open this, it will be here 3, 5, because you can see the quantity of 2 will be 0, quantity of 4 will be 0, quantity of 5 will be plus 1. Now you can solve this. 1 I can written on the left hand side, minus 1, which is minus 2 over pi. So I can, this is minus 1, it is minus minus plus 1, it is minus 1 over 5 plus and so on. Now since I need first quantity to be the positive, I can take negative as a common. It is half 2 over pi, then 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 and so on. So this value will be pi divided by 4 is the right answer of this problem. Look at this another one. Now this is the function is given to you. Now you can see it is equality is not given. Anyhow, whether equality given or not, there is no worry. So you can find the a naught, an and bn. Fine. Look at the denominator. We need a n square. So I have the n square term. It's a plus minus plus minus plus minus. So I need a minus 1 raised to power n also. So I need this quantity also. I need this quantity also. So which one is the remaining? Only this value. Fine. Because 4 is my constant. So I need this value to be 1. So for what value of the x you can choose on, so that cos will be 1. So definitely x will be 0. Fine. So I can take x is 0. So what is the left hand side? F of 0 minus pi square by 3 plus summation n varies from 1 to infinity 4 minus 1 raised to power n over n square. When x is 0, cos 0 is my 1. So it is 1. Sin 0 is 0. So it is 0. Fine. So when x is 0, you will get here. What is the value of the f0? So 0 is the point of the continuous. So I can substitute here 0 minus 0 square. It is minus pi square over 3. I can open this bracket. N is equal to 1 minus 4 over 1 square. N is equal to 2 plus 4 over 2 square. N is equal to 3. It's a negative minus 4 over 3 square and so on. Fine. So I can open this. It is here. Pi square by 3 I can put on the left hand side. I can take negative as a common because I need the first value as a positive. Minus 4, 1 over 1 square, minus 1 over 2 square, plus 1 over 3 square, minus next term is 1 over 4 square and so on. Can you find this number? So it is minus 4 I can put on the denominator side. It is my minus pi square by 12 is the right answer of this problem. Now look at this one. So your target is to prove this one. That means how you can prove that? So that means your f of x will be x square. Fine. And then find the Fourier series of this case. That means your target is to find the a naught, your target is to find the an, your target is to find the bn. So once you can find the a naught, that comes to be my pi square by 3. Once you can find the an, it will be 4 minus 1 raised to power n over n square. Bn will be 0. Substitute this value in the Fourier series, you will get as this expression. Fine. Now look at the first term. If you open them, it will be 1 plus 1 over 2 square plus 1 over 3 square plus 1 over 4 square. It is my here. Now for what value of the x you can choose on. Again look at the denominator. We need a n square. So we have the n square. The numerator is my all positive 1. So which term is unused for you? One is here. We don't need this term and this term. Fine. So it means my target is to firstly choose the value of the x in such a way that this cos nx should be, yes anyone? It should be, because do you need a cos, do you need minus 1 raised to power n? No, because it's all are my positive sign. So it means you have to choose an x in such a way that this value is also my minus 1 raised to power n. So that what is that? When you multiply this number with here, it becomes my, and it is always plus 1. Fine. So your target is to choose an x in such a way that this term will cancel about this term. So when it will be cancel out? Only when your cos nx should be minus 1 raised to power n. So do you remember that? What is the value of the cos n pi? Cos n pi is my here. So that means x should be pi. Clear? Up to so far we have discussed here. In this case we all need as a plus minus sign. But this is the example where we need as a positive n. So that means I can put x is equal to pi. So this left hand side will be my f of pi. Fine. Now what is the value of the f of pi? Fine. But you can see the function is, equality is not there. That means the pi is my discontinuous. Fine. So what is the meaning of the discontinuous? You have to find the limit x approaches pi negative. You have to find the limit x approaches pi positive. And then finally take the average. So what is the limit of the pi negative? Pi negative will be lies here. So that will be my x square. That is pi square. Fine. Or I can write in a more generalized form is f of pi negative f of pi positive divided by 2. That is the value of this case. What is the pi negative? Pi negative is my here. It will be my pi square. What is the pi positive? So pi positive lies outside this case. Fine. Because pi positive is not lies in this case. But we all know the function is periodic. Fine. So once the function is periodic, pi positive is always equal to the pi negative. So this value will be my f of pi negative. Now you know what is the f negative. F negative is my pi square. So this value will be pi square plus pi square over 2. That is my pi square. Fine. So it means this value of the f pi will be my pi square. Always remember, because I have to take an x is my pi. Fine. So if you take x is pi, that lies outside the domain. Again I told you, why not I taken as x is 0? Because if I take x is 0, it is my plus 1. Then this number is not cancelled out. Fine. So now once you got as x is pi square, now can you solve this expression? So I can take an minus pi square on the left hand side. This is my 4. What is this value? This number will be my 1. Fine. So this is mine. Now you can open this. I can take the LCM. 2 pi square by 3. 4. It is 1 over 1 square. 1 over 2 square. 1 over 3 square and so on. So I need this value. 4 I can take on this denominator. So 2 pi square over 12. So it will be cancelled out. So answer is pi square divided by 6 is the right answer. Look at the second answer. For the second part, again the denominator is my n square. I need this value. The numerator plus minus plus minus plus minus. I need this value also. So I need these both value. So it means I have to choose this value so that it becomes a 1. Because in this case I need this value also. So for what value of the x? X is 0. Because cos 0 is my 1. So what is the value of this f of 0? Because 0 is the point of continuous. So 0 is lies inside it. So f of 0 is my 0. Now that is, I think, is very easy for you that you can solve it. When you substitute 1, it is minus 1. When you substitute 2, it is plus, then minus and so on. Fine. Now you can take, because I need a 1 as a positive, I can take minus as a common. It is minus 4, 1 square, minus 1 over 2, plus 1 over 3, minus and so on. It is my minus pi square over 3. So that minus and that minus cancel. Answer will be pi square divided by 12 is the pi square divided by 12 is the right answer. Look at this value. If you open this value, it will be 1 plus 1 over 3 square plus n is equal to 2, it will be 5 square plus and so on. Again, you need it as a n square. But look at the term is 3. Then 4 is missing. 6 is missing. 7 is missing. Fine. It means we can't think about the value of the x. So what you can do, as we have proved these two results, can you think about, if I say this is my equation number 1, can you add equation 1 and 2, or can you subtract equation 1 or 2, or you can multiply equation 1 or 2, or you can divide equation 1 or 2, so that you will get this term 1 over 5 square plus 1 over 7 square and so on. Look at that. Here is 1 by 2 square. I don't need them. So clearly say, if you add them, it will be cancelled out. Fine. So that means if I add 1 and 2, so it will be twice. This will be cancelled out. It will be 2 over 3 square. Then 1 over 4 will be cancelled out. Next one is 2 upon 5 square and so on. The left hand side, right hand side will be pi square by 6, pi square by 12. So what is that? If you take this is 12 is the LCM, 2 plus 3. On this side, I can take 2 as a common, 1 over 3 square, 1 over 5 square, and so on. So you can solve this value, it is my 4, then this number will be divided by 2, that is my pi square over 8 is the right answer. Fine. So if in your examination, if only the third part will be asked, you have to solve the first and second part firstly. Okay, look at this another one. Again, your target is to find this series. Firstly, find the Fourier series as here. Look at this denominator part. We need a n because there is no n square. So I need this value of n. Look at that, it's a plus minus plus minus plus minus. I need this value also. So it means the only unused term is my here. So it means I need this value to be 1. So for what value of the x you can choose from here so that this value becomes my 1. So that means when the sign value will be 1. Sign value will be 1 only when it is a pi by 2. Fine. So I can choose x is my pi over 2. So I can substitute this value on the left hand side. What is the f of pi by 2? Pi by 2 lies here. Its value is my k. Fine. And sine n pi by 2. Again I say this number is not always 1. So you can substitute this value. So it's k and k will be cancelled out. I can say 1 is 2 over pi. When n is equal to 1, this number will be 2 over 1. This is sine pi by 2. Sine pi by 2 is my 1. When n is equal to 2, 1 minus 1, 0. When n is equal to 3, is a negative. 2 over 3. This is sine 3 pi by 2. Sine 3 pi by 2 is my minus 1. When n is equal to 4, this number will be my 0. When n is equal to 5, this is my 2 over 5. This number is sine 5 pi by 2. 5 pi by 2 you can written as 2 pi plus pi by 2. That is my 1. And so on. Fine. So you can see second term will be 0. Fourth term will be 0. And so you can see I can written this pi will be cancelled out. It's a 1. So it is a pi over 2. I can take 2 also as a common. It's a 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 and so on. So can you find this value? Pi over 4 is the right answer of this problem. And this is the required target you want to prove them. That is the required answer. You can put a like so that I can understand that you really enjoy this session as well. Okay, look at one more examples. So firstly, you can find the Fourier series that you can do it by own. Now, look at this denominator part. We need a n square. Fine. Look at the numerator part. I need all as a plus 1. Where is the n square? This is not the n square. This is my n square. Fine. So this n square involve of these values. Cos nx. I only need this value. Fine. So it means, do you need a minus 1 raised to power n? No, because all are my positive. So it means, what is the value you can choose on so that this value will be cancelled out about this. So that means this number should be minus 1 raised to power n. Then only it becomes a minus 1 raised to power 2 and that is my 1. So what value of n? X. Again, we all know cos n pi is, so x will be my pi and pi is the part of this. Fine. Now, what is that pi? So this pi, is the pi belongs to this? No. So that means pi is the point of discontinuous. So once is a point of the discontinuous, it means we need to find f negative plus f positive divided by 2. The right hand side is same as here. Now you can compute the value. Where is the pi negative? Pi negative is my here. Fine. So this value will be my pi plus pi square plus, because the function is my periodic. Fine. The function is my periodic. So f of pi positive is same as of f of minus pi positive. Oh, I think I did it wrongly in the previous case. Where is my case is? Okay, I just here f positive is my minus of f positive, f negative, positive and because of the periodic function. Fine, because f is my periodic function. In the last example where this kind of the question here, I think I have written it is my f positive, but it's a negative. So where is the minus pi? Minus pi. Fine. Where is a minus pi positive? Lies here. So I can substitute this value as, what is the value of f of minus pi? So this value is my minus pi. This value is my minus pi square. Clear? Always remember, because the function is periodic, so it means f of pi positive minus is equal to f of minus pi positive because of the periodic function. Now can you calculate this value? If you calculate this value, it will be pi plus pi square minus pi plus pi square divided by 2. So pi will be cancelled out. It is my pi square. If you substitute pi directly, it will be pi plus pi square. So what is the value of this? It will be pi square. Fine. And this number will be 1. Now you can solve it easily. The only concept in this example is the value of the discontinuity. Pi square by 3. It is, you can open this bracket. So once you can open this bracket, it will be my this example. So you can take 4 as a common, and then you can take on the left hand side. You will get this expression. I can see what is the previous example of the x minus pi square. Which one is the example? This one. Fine. Because here 0 is the point of continuity, so there is no worry about the problem. Okay, look at more examples so that you can learn it many easier way. So firstly, find the Fourier series. You will get this expression. Look at the denominator. I need a n square. In the numerator, we all need it as a plus 1. So where is the n square? This is my n square. So I don't need this expression. I don't need this expression because this is my plus minus. So I can choose this number to be plus 1. So for what value of the x you can choose from here, so that this becomes my 1. So cos of 0 is 1. I can substitute 0. This number is f of 0. This number is minus pi by 4. Cos of 0 is 1. Sine of 0 is 0. So this number will be 0. And this part will be minus 1 over pi n square, where n varies from 1 to infinity. Now what is the value of the f0? What is the left hand limit? Limit x approaches 0 minus is my minus of pi. What is the limit? X approaches 0 positive. It will be my 0. So you can see both the limits are not equal. So that means this is the point of discontinuous. So once this is the point of discontinuous, we have to find the limit as 0 negative plus 0 positive divided by 2. It's a minus pi by 4 plus of this value. Now what is the value of the 0 negative? 0 negative lies here. It is my minus pi plus, where is the 0 positive? 0 positive lies here. It value is my 0. So what is the value of the f0? f0 will be minus pi over 2. So I can substitute this value as minus pi over 2, and this value I can substitute n is 1. It will be my minus of 2. When n is equal to 2, this number becomes my 0. When n is equal to 3, and so on. Now the rest of the part is simple. You can simplify it to get this value. Minus pi by 4 is given as plus pi by 4. I need all as a positive. I can take a minus of 2 common. This value will be 1 over 2 square, 1 over 3 square, plus 1 over 5 square. Now 4 is the LCM. It will be my minus pi. Minus 2 pi plus pi is pi, minus 2 over pi of this number. So what is the answer of this? This minus and minus cancel out. It will be pi square divided by 8 is the right answer of this problem. Look at this another one. Again, firstly find the Fourier series. Denominator is n square. I need them. And in the numerator, I need only as a plus 1. So I need to choose this value, so that because it has more than one element, so I can choose this number to be 1. So for what value of the x? X will be 0. Fine. So once x will be 0, you will get cos of 0 is 1 here. What is the left hand limit? At x approaches 0 minus, this value will be 0. What is the right hand limit when x approaches 0 plus? Then 0 plus, it is a minus 0, that's a 0. So you can see both are equal. So that means this is the point of continuity. So continuity means that limit is the same one. So minus pi over 2 plus, I can open this bracket. When n is equal to 1, it is 2 over 1 square. When n is equal to 2, it's a 1 minus 1, 0. When n is equal to 3, 2 over 3 square, and so on. Can you find the value of this quantity? That is this one. That minus pi by 2 on the left hand side. I can take 2 as a common. It's a 4 over pi, 1 square, 1 over 3 square, and so on. So what is the answer of this? Pi square divided by 8 is the right answer. Okay, look at this another one. That's again a very simple. You can find the Fourier series. Denominator will be n, and it's a form of the plus minus 1. So I need the value of this to be 1. So when the sign value should be 1, when this will be 1, when it will be the pi by 2. So that means x need to be pi by 2. So what is the value of this? You can substitute x is pi by 2. What is the value of the pi by 2? Pi by 2 lies here. Fine. So this number will be 1. It is my 3 by 2 minus 1 over 2. Now you can substitute it. When n is 1, it is my 2 over 1. Sin pi by 2, 1. When n is equal to 2, 0. When n is equal to 3, it is my 2 over 3 sin 3 pi by 2. What is the sin 3 pi by 2? Minus 1, and so on. You can write this value here. Now your target is to find this number. 3 by 2 I can put on the left hand side. I can take 2 as a common. It's a minus 2 over pi. Then it's a 1 minus 1 over 3 plus 1 over 5, and so on. And you can see I need this number, and this is the value of here. So I can solve. The left hand side is my this into this number. So can you find this value? It's a pi divided by 4 is the right answer of this problem. So sorry, it's a pi by 4. Pi by 4 is the right answer. Okay, look at this another one. You can see this is another category where you need a 1. It's not a point. It's a 1 into 3. This is a 3 into 5, and so on. So as I told you, once you can compute the Fourier series, you can see it's a sine. Fine. What is the x angle is? 1. So it means you need to find an, you need to find bn, you need to find a0, and because of this x coefficient is 1, you need to find a1 separately, b1 separately. Fine. If it is my say sine 2x, then you need to find this. Because of this 2, you need to find a2 separately, b2 separately. Anyhow, that you can find the Fourier series that you will get as here. Now, how you can look at that? This denominator 1 into 3. Firstly, is the product of the two terms. So I can return 4n square minus 1 to be 2n minus 1, 2n plus 1. So clearly say the nth term will be my here. The numerator becomes my plus minus plus minus plus minus. That means I need a minus 1 raised to power n, but it is not given. Fine. It means for what value of the x you can choose on, so that this value becomes my here, because I need this number as a plus minus plus minus. So for what value of the x? We all know cos n pi will be minus 1 raised to power n. So for what value of the x, so that it becomes a n pi, only when x is pi by 2, so that this 2 and this 2 will be cancelled out. So I can substitute x is pi by 2. Fine. When you substitute pi by 2, sine pi by 2 is my 1. Fine. It is my n pi. What is the value of the pi by 2? Pi by 2 lies here, and sine pi by 2 is my 1. So is 1 over pi plus 1 over 2 minus 2 over pi. It is minus 1 raised to power n. This number I can written as a 2n plus 1, 2n minus 1. That's over. I can put this well number on the left hand side. It's a minus half on the left hand side, minus 2 over pi. Now when you substitute n is 1, minus 1, 1, 3. When you substitute n is 2 plus 1, 3 into 5. When you substitute 3, so it's a 5 into 7 and so on. Now you can see it's a 1 minus, it's a 2 pi is LCM. Fine. So it is my 2 pi minus of 2 minus pi, which is minus 2 over pi. I can take a negative as also common, because I need a 1 over this as a positive number. So this is 1 into 3 minus 1 into 3 into 5 minus plus 5 into this and so on. So what is this number is? 2 pi minus pi is pi minus 2 over 2 pi. This number I can taken as, so what is the answer of this? Pi minus 2 divided by 4 is the right answer of this problem. We will see the next lecture on the Fourier half-range series. I hope you can like and comment on my video as well. We will see the next lecture on the Fourier half-range series with the help of the various examples. Till then, you can comment on my video, share with your friends. Best of luck, students. Happy learning.